In this video, we're going to be doing arithmetic of complex numbers. Now, arithmetic, we have our four arithmetic operations. Four arithmetic operations are addition, subtraction, multiplication, and division. And complex numbers are a special kind of number. The standard that we'll be addressing is a high school standard, Algebra 2, and it's perform arithmetic operations with complex numbers. So first off, what is a complex number? So this is all this is saying if let z be a complex number, this means that z is letting z be some variable. It's saying z is a member of this set, and this set is the complex numbers. The c as the notation for the set of complex numbers. So this just means let z be a complex number. Then z is equal to a plus bi, where a and b are real numbers and I is the square root of -1. So this is kind of the basic format of all complex numbers. There's a real part and there's an imaginary part. And they're kind of like coefficients, and the I can kind of sometimes be treated like a variable, although it is constant, but it differentiates the terms and makes, and that's why we have two parts. So let's do addition of complex numbers. Now addition, the main thing I wrote here was combine like terms, because that's basically just what we're going to be doing. We have two real parts, and we have two imaginary parts, and they're kind of like terms, so we can just combine them. I'll rewrite this without the parentheses, so this will turn into 2 minus 3i plus minus 4 plus 5i. Now I'm going to group together the like terms, so we'll have 2 minus 4 for the real part, then we'll have negative 3i plus 5i for the imaginary part. Now we're just going to combine them and simplify either the constants or the coefficients. So this 2 minus 4 will turn into a -2. And then this negative 3i plus 5i will give us a positive 2i plus 2i. This is our answer for adding these two complex numbers together. And again, our solution is also a complex number, of course. And there's a real part and there's an imaginary part. That actually means that the set of complex numbers is closed under addition. Because the sum that we end up afterwards is also a complex number. There's no way to add two complex numbers together and get something that's not a complex number. There's for subtraction of complex numbers. Now the main thing here is basically just like the addition of complex numbers. We're just going to be combining like terms, but the only other thing is that it has an additional first step, which is kind of distributing the negative. So there's a negative here. We're going to distribute it to the second part, because we're going to change those signs. So I'm going to rewrite it again. We'll have -6 plus 7i. Now I'm going to distribute the negative, so we'll turn to a -8 and then a positive 9i. Now we can combine like terms again. So we have the -6 minus 8 for the real part. Then we have the 7i plus 9i for the imaginary part. -6 minus 8 gives us -14, and then for the imaginary part, 7 plus 9 gives us 16i. So this is the answer for this subtraction of these two complex numbers. Let's move on to multiplication. Multiplication is different than addition, of course. We're going to be multiplying these two complex numbers, and the main thing here, if you know how to distribute to binomials, then you're pretty golden for these multiplication of these two complex numbers. So let's just distribute these. The first term would be, or I can rewrite it out, 1 times 3. The next one will be 1 times -2i for the first two terms. Now we have, next one would be 4i times 3. The next one would be 4i times -2i. Okay, let's multiply these out. So we get a 3 here, we get a -2i here, we get a plus 12i here, and we get a -8i squared here. Now what do we do with this I squared? I squared is equal to -1, which makes sense because I is equal to the square root of -1. So if you square it, you just be left with -1. So if I is equal to -1, that would turn into -8 times -1. That'd be a positive 8. So that's what that'll turn into. Now for the middle part, we can combine the -2i and the 12i to give us 10i. So we'll keep the 3 because we haven't done anything with that yet. And then the -2i and the positive 12i gives us a positive 10i. And then we have the plus 8 from the right. So that's what this expression would turn into. Now we can combine the 3 and the 8 to get us 11 for the real part, and then plus 10i for the imaginary part. That's our answer for this multiplication problem. multiplication is also closed, or the complex numbers are also closed under multiplication. Whenever we take two complex numbers and we multiply them, the solution is always going to be a complex number. Although it may only have a real part, the complex number can very well be 0, and then it could just be a real part, where it would be just a real number. But real numbers are a subset of complex numbers, so even if it is just the real part, just a real number, it is technically also considered a complex number. Next up would be division, and the main thing I wrote here was conjugate. Now the way we do this division, we want to do something to this ratio to get rid of the I in the denominator. The way we get rid of the I in the denominator is that we multiply the top and bottom by the conjugate of the denominator. So the denominator is 4 plus I. The conjugate of 4 plus I is 4 minus I. It's the same thing, just the sign in the middle is switched, or the sign of the imaginary part, more specifically, is switched. If it's positive, then it turns into negative. If it's negative, then it will turn into a positive. Now, at this point, it just turns into two multiplication problems. We have negative 3 plus 2i on the top times 4 minus I, all over 4 plus I times 4 minus I. Now, let's just perform the multiplication. So on the top, we would have negative 12 plus 3i, right? Negative 12 plus 3i, and then plus 8i, and then minus 2i squared. So that'll be what we have on top. On the bottom, we will have 16 minus 4i plus 4i minus I squared. Okay, let's start simplifying some things. So I'm gonna combine some steps. I'm gonna combine the imaginary parts, and then also rewrite these in terms of just constants, because I squared is equal to negative 1. So we'll have the negative 12 on top, and then the plus 3i plus 8i, that'll be plus 11i, and then the negative 2i squared will turn into a positive 2. All right, okay, now for the bottom, we'll have the 16. Now the negative 4i and 4i goes to 0, so there's no imaginary part, which is what we want. We don't want an imaginary part in the denominator. And then the minus I squared gives us a minus negative 1, which is just plus 1. Okay, so we're looking pretty good. We can start simplifying some more. So on the top, we'll have negative 10 plus 11i all over 17. Now we're almost there. We're almost in a plus bi form. We just got to identify the a and b. So this would be negative 10 over 17 plus 11 over 17i. So this is in a plus bi form. A and b in this case are both rational numbers, or they're fractions, but rational numbers are still real numbers, so this is still considered a complex number. Okay.